right, ladies and gentlemen, so today we're working on lesson 9.5, and we've been working on this whole idea of squaring, and then we talked about perfect squares, and now we're going to be continuing that discussion, and we're going to have it as part of an equation so that eventually we can solve and finish solving those Pythagorean theorem questions, because we've had to stop right now if it wasn't a perfect square. So we know we're talking about positive integers. So if I have the problem of x squared equals 4, we're trying to figure out, well, what does x have to equal? So we're basically saying, is 4 a perfect square, which it is. So what times itself gave me 4? Well, we know that 2 times itself gives you 4. So x would have to equal 2. Now, let's try another problem. If c equals 3 and d equals 4, compare the numbers c and d and the numbers c squared and d squared. Well, if c is 3 and d is 4, then we know c has to be less than d, right? c is 3, d is 4, 3 is less than 4. All right, well, now let's square them, right? That's what our exponents mean. So if I have 3 squared is 9 and 4 squared is 16, well, 9 is less than 16, which means c squared has to be less than d squared. So, can c ever equal d? Well, no. 3 cannot equal 4. That never, ever, ever, ever can happen, right? That goes way back. I know it seems kind of silly, but that goes way back to when you were in elementary school and you first started counting. Okay, can c ever be greater than d? No. 3 is always less than 4. Always. All right, well, the idea behind this is that saying that if you have numbers that are less, one is less than the other, anytime you square them, your answers are still going to be less than the other one, whichever one was smaller. Okay, so down here we have 2 charts, and the charts are related. So the numbers in one get to, in the first column get to the second column. We're doing something, and we're trying to figure out, well, what are we doing to get there? All right, so I'm going to give you guys a couple of seconds, couple of minutes to look at it. I want you to try it, and then I want you to come back and see what you think. Okay, so let's see how you did. So my guess is that the first chart was probably a little bit easier, being that we had just gone through and done our perfect squares. So in this chart, to get from the first column to the second column, we're squaring our numbers. Which means if you had to fill in, like, for example, the 9, you were looking for the square root. So to go from one to the other, we were squaring, and then to go from here to here, we were doing the square root. So right along those same lines, in this chart, we were doing something a little bit different. And it might have looked a little weird, like, okay, I got from 1 to 1, and okay, that's the same. Well, 3 to 27, 6 to 2, 16. So you kind of had to look at the few that were filled in completely for you. But to get here, we were cubing a number. Right? That meant that we were taking whatever's over here and we were multiplying it by itself 3 times. All right, and that's how we were getting those numbers. So then the reverse over here is something called the cube root. And that's one thing we're going to be talking about today, is how to solve equations that have cubed roots and square roots in them. Okay, let's go to the next page and get some vocabulary. So the cube root is the number multiplied by itself 3 times. So my symbol, it looks a lot like the square root symbol, but we actually go and we put a little 3 in there, and that's telling me that I want to take the cubed root of something. So cubing, multiplying it by itself 3 times, and cube root are opposites, just like squaring and square root are opposites of each other. So when I want to go through and do an equation, I have to take either the square root or the cubed root of the number. So if I want to figure out what x is, I have to take the square root of both sides. Squares and square rooting cancel each other out. So this is going to leave me with x. And over here, I'm saying, well, what's the square root of 25? What times itself gave me 25? And the answer is 5. Now, over here in number 2, I have this negative exponent. We have to remember way back when to September, when we know that a negative exponent means I have to turn the problem into a fraction. So I have to do that first. Now I can take the square root. Well, when I'm taking the square root of a fraction, or a cubed root, I'm really doing the square root of the top and the square root of the bottom. So the square root of 1 is 1. Square root of 25 is 5. So in this case, x would have to be 1/5. Here's an example of my cubed root. So I'm going to rewrite it just so that I can fit my symbols in. So I need to take the cubed root of each side. Well, cubing and cube root cancel each other out. And I'm saying, well, what times itself gives me 8? What times itself 3 times? And if you go back to the little chart we had filled in, that number would be 2. You can do that on your calculators, right? But 2 times 2 times 2 gives me 8. I know a lot of you are thinking that it's 6, and it is not. Okay, a square-shaped park has an area, right? So whenever they're giving you something about a shape, draw it out so that you can see. So we know we have the area, and in a square we have all the sides the same. Write and solve an equation. Well, to find the area of a park, right, it's side squared. Well, let's fill in what we know. We know the area is 324. We know our side is x. Well, now that looks just like what we did up here in number 1, except the x squared is on the other side. So I'm going to take the square root of both sides. And honestly, I do not know what the square root of 324 is. So we'll figure that out real fast. Oh, it's 18. So x is 18. They told me a label, so 18 feet. All right, I want you to try these on your own and come back and check to see how you did. Okay, so let's see how you did. For number 5, you had to take the square root. You should have gotten x equals 13. Number 6, square root of 625 is 25. For number 7, you had to now know and remember a couple of things from earlier in the year, that the volume of a cube is side cubed. So I filled in the 27, I filled in x for the side, and then I had to take the cubed root, which was 3, because 3 times 3 times 3 is 27. Number 8, what positive value of x makes the following equation true? So I had to take the cubed root. They also wanted me to explain. Well, your explain is kind of your check. So I said x equals 4 because 4 times 4 times 4 equals 64. So hopefully nothing too confusing there. So the idea that we have cubed roots and square roots, and they cancel out squaring and cubing. Any questions? As always, bring them to class. Have a good day, guys.